Hello students, I am Ashish De. I am taking one of your subject, that is digital signal processing. In my earlier video, I have discussed about operation on discrete time signal. In this video, I want to discuss about discrete time system. Now, what is discrete time system? A discrete time system is a device or an algorithm that operates on a discrete time input signal according to some well defined rule to produce another discrete time signal yn called the output signal. So a discrete time signal, suppose this is the discrete time signal, discrete time system. So this is the discrete time system. It has an input of xn and output is yn. So xn is also a discrete time input signal and yn is the discrete time output signal. Now the relationship between yn and xn is that yn is equal to transformation of xn. So this is discrete time system. Now classification of discrete time system. What are the classifications? There are various classification of discrete time system. They are static and dynamic system, causal and non-causal system, linear and non-linear system, time variant and time invariant system, FIR and IIR system, stable and unstable system. So those are the classification of discrete time system. Now static and dynamic system are not in your syllabus. A discrete time system is called static or memoryless if its output at any instant n depends on the input samples at the same time but not on past or future samples of the input. In any other case, the system is said to be dynamic or to have memory. Now causal and non-causal system. So this classification is very much important, that is causal and non-causal system. Okay, so a system is said to be causal if the output of the system at any time n depends only at present and past input but does not depend on future inputs. This can be represented like this way. The output of the system yn is basically transformation of xn x of n minus 1, or it may be function of xn x of n minus 1 x of n minus 2, like this. So these are basically present value and past value. Here the present value is n, so this is the present input and those are the past input. Okay, so this is causal system. An example of causal system is yn equal to xn plus x of n minus 1 and yn equal to, so this is causal system. And an example of non-causal system is yn equal to x of 2n. So this is non-causal system. It depends on the future inputs. Okay, so it is non-causal system or anti-causal system. Now how to check whether a system is causal or non-causal? Suppose an example has been given, yn equal to xn plus 1 by x of n minus 1. So this example is given. We have to check whether this system, the system governing the input output relationship by this equation, is causal or non-causal. Okay, so at first we have to write this is equal to transformation of xn. Okay, now just check y of minus 1. What will be the value? X of minus 1 plus 1 by x of minus 2, right? Now y of 0, that will be equal to x of 0 plus 1 by x of minus 1. Y of 1 equal to x of 1 plus 1 by x of 0. Okay, so for all the cases, the output of the system depends on present and past inputs. Okay, that's why this system is causal. So this system is a causal system. Now an example of non-causal system. Suppose the system is given by yn equal to x of n square. This is non-causal system. Why? Y of minus 1 will be equal to y of 1, y of 0 that will be equal to x of 0, and y of 1 equal to x of 1. So here in case of y of minus 1, the output of the system depends on the future values of input, because here is x of 1, so it is future value of input. Okay, and all other cases for 0, for when the value of n is 0, then y0 equal to x0, so it depends on present input. Again, when y1 equal to x1, it depends on the present input. Okay, but in this case, in the first case, it is depend on the future input. So this is non-causal system, right? So this is an example of a non-causal system, right? Now the most important classification, that is linear and non-linear system. So linear and non-linear system, this is very much important. A system that satisfies the superposition principle is said to be a linear system. Now what is superposition principle? Superposition principle states that the response of the system to a weighted sum of signals should be equal to the corresponding weighted sum of the outputs of the system to each of the individual inputs. Mathematically, it can be represented by transformation of a1 x1 n plus a2 x2 n will be equal to a1 transformation of x1 n plus a2 transformation of x2 n. So this is if a system satisfies this condition, then the system is said to be a linear system. Otherwise it can be said as non-linear system, right? Let us take an example. Suppose given that yn equal to xn plus 1 by x of n minus 1, we have to check whether this system is linear or non-linear. Okay, so at first we have to write that this is equal to transformation of xn, right? Now y1n will be transformation of x1 n equal to x1 n plus 1 by x1 n minus 1. Again, y2 n will be equal to transformation of x2 n, so that will be equal to x2 n plus 1 by x2 n minus 1, right? Now weighted sum of input, that will be equal to the result is saved in y3n, that will be equal to transformation of a1 x1n plus a2 x2n, that will be equal to in the same format it will be equal to a1 x1n plus a2 x2n plus 1 by a1 x1 n minus 1 plus a2 x2 n minus 1, right? Now this is not equal to a1 y1n plus a2 y2n. Okay, so the given system governing the equation yn equal to xn plus 1 by x of n minus 1 is non-linear. So this is non-linear system, non-linear. Okay, so this is very much important, just practice this. Now another classification is time variant and time invariant. Time variant and time invariant system. A system is said to be time invariant or shift invariant if the characteristics of the system do not change with time. To check whether a system is time variant or not, we have to first delay the input by k units, again the delay the output by k units. If both the results are same, then the system is said to be time invariant, otherwise the system will have to be said time variant, right? Let us take an example. Suppose yn is given by xn plus x of n minus 1. We have to check whether this system is time variant or time invariant. So at first we have to written that this is equal to transformation of xn, right? So if we delay the input xn by k times, then y of n comma k, that will be equal to transformation of x of n minus k. So this is the input is delayed by k times, right? So this will be equal to x of n minus k plus x of n minus 1 minus k. Again, if we delay the output, then y of n minus k, that will be equal to x of n minus k plus x of n minus k minus 1. Now both are same. Since both are same, this system is time invariant system. So this is time invariant. Okay, now a system which satisfy the time invariance property as well as linearity property, then the system is said to be linear time invariant system, okay, or LTI system. LTI, it can be called as LSI, linear shift invariant also, because time invariant and shift invariant both are same thing. So from this video what we learn? We learn how to check whether a system is causal or non-causal, whether a system linear or non-linear, again whether a system time invariant or time variant system, and which system is called LTI system.